Okay guys, today we're going to be looking at Pythagoras' theorem. Okay, Pythagoras was a mathematician who was alive in the 6th century BC, so well before Jesus, right in the middle of Greece's classical period where there was a lot of thinking, a lot of philosophy, a lot of science and that was going on, right at the fundamental levels of these disciplines, okay? Pythagoras, or his school, the people that were around him, came up with the famous Pythagoras' theorem, and he investigated these things called Pythagorean triples, which are right-angled triangles. You know, a triangle that has one of the corners being a right angle, where it had whole numbers as the side lengths, okay? So all three sides were whole numbers, okay? Both the Babylonians and the Egyptians discovered special triangles, like right-angled ones and things. But Pythagoras and his crew sort of were the first to express it mathematically, to write it down and to prove it and to put some logic behind it, okay? Now, what does it look like? For some of you, it will be very beneficial to see this graphical representation of the Pythagoras theorem. We'll also be doing some stuff in class, or have done some things in class, that are allowing you to see this physically and play around with shapes and see how it works. But if I've got a right-angled triangle here, and we can tell that it's right-angled because not only did I draw it like that, but I've said that it is by putting the little sign here in the corner. So I have 3 length here, a length of 4 here, and a length of 5 across there. Okay? Now if I extend this 3 out and make a square of it, with 9 squares in it now, and this one here becomes a square of 16 squares, because 4 times 4 is 16, and this 5 one is 5 by 5, which is 25 squares. Now, those of you who are quick on the nose can figure out that 16 plus 9 is 25. Okay? Now this is really getting to the fundamental of ridiculously cool things about maths. That the fact that right-angled triangles work out like this all the time. Okay? So, this is the formal statement sort of thing of the Pythagorean theorem. So, a square made from the long edge of a right-angled triangle is equal to the sum of squares made from the short edges. Okay? So if you make a squares of the short edges, smash them together, and they'll add up to the same as a square made from the big edge. Okay? That's what it looks like, Pythagoras theorem. Now, nuts and bolts level, key ideas for our Pythagoras theorem. We have, this long edge has a special name. Special name is the hypotenuse, okay? Hypotenuse. Hypotenuse means under tension. See, the Egyptians used to use ropes of 3 units and 4 units into a triangle, and then the other one would be 5 units, right? And so they'd place the rope under tension to be able to get that length properly, okay? So that's why we get this from the Greek words for under and tension and things. So, this hypotenuse thing is 2 things: the longest side, okay? The longest side of a right-angled triangle, and it is opposite the right angle, alright? So the longest edge is always going to be opposite to the right angle anyway. It's just sort of super explaining stuff. Right, and here's our theorem. So, I'm going to call these sides A, B, and C, okay? And this is the way you'll see it written a lot, and this is the way we're going to use it in class and in your mathematics. You've got a squared plus b squared equals c squared. Okay, so remember before we saw that a square made of the big side, so c squared, is equal to the sum of the squares of the shorter sides. Okay, so this is Pythagoras' theorem, okay, written in mathematical notation. Alright, let's have a quick look at how we're going to use this. There's really 2 ways that you'll be using this at the moment. So the first one is, let's have a look at the second one here first, because that will make a lot more sense. Okay. finding the length of a hypotenuse for a right angled triangle. Okay, so here we have a right angled triangle, right angled, we've got a hypotenuse here and it's not known. Okay, we've got 6 for this edge, 8 for this edge, and we don't know this one. Let's say we need to find it out. So we maybe need to make a joist or something, and we need to know exactly how long the steel beam is going to be to prop up a wall against a floor or something. Okay, right. First off, we state our theorem: a squared plus b squared equals c squared. We saw that before. Now, what's going to really help you when you see these problems is, even if this isn't called c, it could be called x, elephant, whatever. Doesn't matter. Rewrite them as these 3 letters, A, B, and make sure C is the hypotenuse, okay, so you don't get yourself in trouble. Secondly, sub in the values and solve it. That's as simple as this is. So, A, that's 6, B, that's 8. So 6 squared plus 8 squared equals C squared, okay? 6 squared is 36, 8 squared is 64, equals C squared. 36 and 64 is 100. Equals C squared. Right, here's a new skill. You may not have seen this before, may not have used it before. Here we go. I want to get the C on its own, okay? To do that, we need to take the square root of both sides, alright? Square root is the opposite, the inverse of taking the square of something, so it kind of takes away the squareness. And we're left with C equals 10, because the square root of 100 is 10. Done, okay? That's really easy, guys. You're just subbing it in, taking the square roots, done. Okay. Lastly, the other way that we're going to be using this is finding the length of a short side. Okay. So we might be talking about this could be a bridge or something. We need to lower a rope down, know how long it's going to be. So what we'll do, we've got 5 and 4. So 5 is our hypotenuse length. 4 is one of the short side lengths. And A is our unknown, okay? So first thing, you probably want to write down B and C. So put B as the other short length, and make sure C is attached to your hypotenuse, your longer one. Right, state the theorem. A squared plus B squared is C squared. Sub in our values. B is 4, C is 5. 4 squared is 16, 5 squared is 25. Right. Remember, we just want a squared, so we're going to take 16 away from both sides to get rid of this 16 here. And so we'll have a squared plus 16 minus 16 equals 26 minus 16. So 26 minus 16 is 9. And so we have a squared is 9. Again, here's our new skill coming in. Take the square root of both sides. Because you just want a by itself, not a squared. So the square root of a squared is just a, gets rid of the squared nature. Maybe I'm going to do this crazy thing and put an equal sign in here. Square root of 9. Square root of 9 is just simply not 9, it's 3. So the square root of 9 is 3, so therefore A is 3. Okay, you might recognise this triangle from the graphical representation that I showed you. So, this is Pythagoras' theorem in a nutshell. There's only really 2 ways that we're going to be using this. There's not a whole lot more ways of using Pythagoras, but it's a good grounding for trigonometry, and again, you're using some more skills and just building and adding to that algebra toolbox that we're building, okay? So, watch the video again if you want to have a bit more of a shot. Try and grab some stuff from your text as well in the Pythagoras section, and get prepped for class, and I'll see you then.